to part 2 of Competency 12 quiz. In this video, we will continue working with data and measures of central tendency. Number 7, what is the IQR of the following data? Okay, this is from the prior question, which we already have populated, okay? So let's look at our data list. So there's data. Okay, I have it populated in L2. Okay, so that's L2. So let's use our calculator to figure this out. All right, so second data, we still need the 1 var, okay? And we have it on L2 and 1, which is what we need. So enter, and we need Q3 minus Q1. Arrow up till you see all of those. Yes. So 36.5 minus 16.5 is obviously 20. Okay. Now, if the number is actually, or the value is actually larger, you would want to back out and enter that in your calculator instead of doing that in your head. Okay, let's look at number 8. Let's take this down a bit. Okay. Number 8, the graph below shows the number of questions each student answered correctly on a 75 question test in relation to the number of hours each student studied. If the student studied 11 hours, how many correct questions could the student have on the test? Okay, first off, you can't go over 75 correct questions. That doesn't make sense. So automatically, D is out. It just doesn't jive, right? Okay. Well, it's one of those questions, either you catch it or you don't. Okay. Now, when we teach this to the students, which would be 8th grade, okay, or your 7th graders that are in that specific kind of class, right? Whatever you call those classes. All right. You probably would have them draw on something clear, like a patty paper, or fold the patty paper and make a straight line. And then you need to move that line around until you got a good fit, meaning the same number of dots below the line and above the line. Okay, so I'm going to use a ruler, which I've got mostly adjusted to the right degree, positive degree up. And as you can see, this is a positive, strong correlation. So I'm going to put it right on some of these dots. See how I've got them touching and in between a couple? Okay, not the best, but good enough. Now I could go down slightly here. Might be a little bit better. Okay, so let's see. I have 1, 2, 3, 4, 5, 6, 7, 8. If I wanted to go down a little and touch that one, right? Go in between those two middle ones. Okay, about 8. Okay. It's not great. We should tilt it a little more. But if we went right on those, that looks better. And I have 1, 2, 3, 4, 5, 6. Okay. So now let's move this up and see. We can see through the ruler for the most part. Put it right back on those. And let's see right in there. I see 1, 2, 3, 4, 5, 6, 7. Well, that's not bad. Okay. That's close. I could move the ruler a little bit down and up, but either way, it doesn't matter. And I'll tell you why. Because we know we have over 70 questions. It's going to be over 70. In that case, I would say 72. We know it's not below because we wouldn't have the right amount of dots above and below. Okay. It's kind of how you play the game, right? Really, you see how we have some of these dots close together? Really should move this ruler a bit, but it's kind of hard to do while I'm trying to run my video. It doesn't work out well, so I'll spare you that. But the truth is, 72 is actually the best answer. Okay, let me move my ruler so you can see. See how my ruler is going above? No matter what I do, I'm not going to be moving my ruler down. It's going to be a more steep slope, not a flatter slope. Okay, that would make sense. So it is above that, and I would say about 72 is my best guess. And that's the thing about scatter plots in this particular kind of question. There isn't a perfect answer. There is the best answer when you have the same number of points above and below the line. It's a skill to in a property that you should know, and it's really tough for students. Anyway, just be aware of it. All right, let's move on to number 9. Number 9, which scatter plot does not suggest a linear relationship between the x and y values? Okay, well, let's look at them one at a time. A, that would be a strong negative linear correlation. You can put a line of best fit through it very nicely. Straight through, same amount on the bottom and top, so that won't work. C, well, no, let's look at B first. That's obviously close to a perfect positive correlation, so B won't work. Now, C, just because it would be a horizontal line that would give a best fit, which is close to a no slope, as you see from our examples in our prior videos. Remember, I said familiarize yourself with these particular kinds of lines. This is still going to qualify as a linear relationship, although close to no slope, doesn't matter. And we're looking for no linear relationship. So that's not going to work. Okay. Now, you may want to look at D and say, "Oh, I could draw a line through that and make it well, I have the same number on the bottom and top." Actually, you really can't. Not evenly at all junctures. You're going to have a part of the line where they're all below and part of it where they're all above. It's not going to be a nice spread of above and below properly. Look at the others and think about it. What you really have is a curve going down and like this. You really can't draw that nice line. So if I start here and I try, what I'm going to do is really more of it at each section is all below, and then at another part of the section, they're all above. That doesn't qualify for what I meant as the same number above and below. You really have to look at each spot you're at and analyze it, okay? So that isn't going to work, okay? So this one is a non-linear relationship, okay? All right, it's got a type of curve, but not really what we want. We might have even be able to do this and get it to work better like this. Although if you want it to be more precise, the yellow, either way, this is not linear. Okay, that's the point. So D is what we need to answer that. Okay. All right, let's look at number 10. Okay. You wanted to determine whether a correlation exists between overall grades and the number of hours students spent practicing calculator use. Well, this is a little different than the other question. The table gives the data from 8 students where X represents the number of hours spent practicing the calculator and Y represents each student's grade. Okay. And they said overall grade. So, like, that's for the whole class, math class, obviously, because a calculator makes sense. What is the value of the correction? Yeah, the correction coefficient R. When we've gone over these in other videos, and I'm sure you study them, everybody sees these at some point in math class, right? Okay, so what do we need to do? I'm going to be honest with you. Let me push data. That I have, our X is in L1. However, our Y is populated in L3. And this is a two variable situation because they flat tell us it is. All right, so let's set this up. Second data, go down to two variable stats. Okay, enter. Ah, so we want to use for the x's, we're in L1, highlight that. And the y's are already in L3, so we're okay. All right, so we can just enter and calc. Okay, so we have calculated. Now what do? Well, arrow up until you see that R. There we are. So we have our A, our B, and our R. Well, it is obviously a pretty strong positive correlation. So yes, calculator use and practicing with it does help, which some of us know if you go to take a test, you do know it helps. All right, and that's what we're trying to learn here. So looks like option B is what we need. Great. Okay, this is the last question in this video. Okay, actually for this particular competency. Thank you guys so much for watching and liking and sharing. And some of you have been on our new website, numbersarenadical.com. Truly appreciate it. And congratulations to those of you who have passed your test. Kudos to you. Happy testing, everybody.